So thank you for being here. Thank you to all the organizers and to Jane, who knows why. So it's my first time giving a talk in England, in the UK, and in English for that matter. So please be indulgent if there is any problem. So today we're going to talk about what is it like to be a fish, and I will explain in a second why I'm explaining that. So at first, I will explain briefly my work, why I'm here and why I'm going to talk about fish in an animal activism conference. Then we will talk about who are fish. So just briefly, when I'm starting to talk about fish, for example, I give a course in a vet school and it lasts for 7 hours. We don't have, well, actually I have 7 hours for the hardcore ones, but now we just have 45, 50 minutes. So I just grab some of the most interesting things we have on fish to show you that they might be more interesting than we tend to think. And then we'll go to the question of how to assess sentience in animals, and especially in fish, because there has been a very big, annoying debate about fish sentience that happened during the last 10 years. So we'll go briefly on that. So first, about my work. So from zero to hero, and that's massively exaggerated. So at the really basis, I'm an animal rights activist, as everybody around here. Started like 15 years ago. Yeah, I'm already taking too much time. But the idea was I couldn't find a proper spot for me there, and I arrived there by philosophy and by ethology, which is the study of animal intelligence and behavior. But just to put things straight right now, I am not a scientist, and I don't even have any diploma in science, which is why it's getting pretty crazy right now. So I've started to make YouTube channels. So this is the different things I'm doing. I have a YouTube channel. So most of the things I do are in French, but on the YouTube channel, there are some English subtitles. I wrote books, I give lectures, and lots of other stuff. Basically, I'm working on animals that people usually despise or exploit. So in France, today, I'm pretty much Mr. Fish, because I've done massive reviews on the literature, on the scientific literature on fish. And today in France, I probably belong to a very few number of persons with a general overview. I wrote a book about that had some prize. And yesterday I got a prize from the biggest association of animal cognition and behavior scientists. So my work is now pretty much recognized. Oh, no, I didn't say that for this. But these books have been prized as well. This one is about farm animals, and it's a kind of comic book with a review of 455 studies. So it's a very strong thing that is now used in academics, scientists learning farm animal cognition are using my books. So I'm sometimes giving expertise for NGO, for associations, for governmental research institute, for many different things, for TV. I even participate in a long documentary about fishing on the Fish Channel, the biggest one in France, where my last sentence is fishing is bringing the biggest amount of pain in all the waters in the world, and the documentary had a lot of success. So I'm going to TV, and this book is a very recent one I wrote with a European deputy who is fighting for the fish at the European level. So yeah, basically it's just crazy what's happening now, because I'm doing a lot of counsel, and now I'm pretty much working with academics a lot, which is very interesting because I don't have the position of an open activist anymore, because my goal is to take really good information, really reliable information to give to everybody, whether they are activists, so you know very well who are the animals you are fighting for, to avoid anthropomorphism, and also giving reliable information so we'll look stronger on our basis, but that also allows me to have influence. Like now I've met different young scientists who told me that they started studying because of my work. So this is slightly, slowly changing things, and it's starting to have influence inside the reflection. So it was already too long. So, who are fish? Yeah, we don't have 7 hours. We'll go very fast. When we're talking about fish, we're talking about more or less, depending on the sources, 33,000 species. It is more than twice the birds and mammal species. So when people call me to talk about fish, I'm like, okay, what fish? Because it's like asking me to talk about mammals and birds. Well, I'm sorry, but a raven is not the same thing as a rat, which is not the same thing as an elephant. And this is important because this is what we have to understand about fish. We can't decide, we can't push laws, rules, regulation, welfare if we don't know anything about fish. And today we know hardly anything about fish, let's be clear. So, for example, we have fish that can breathe out in the air. This one has to go in the air to breathe. We have fish with no scale. We have fish that have the 2 eyes on the same side of the body. It's messy. We have fish that can see in UV. We have fish that do electricity. It's just purely random. But it's normal because they live in a lot of different areas. Probably more than mammals and birds, because you have rivers, you have ocean, you have the biggest depth, you have pretty much everything, and they adapt to it. So it's not surprising that, for example, in the hearing abilities, you have pretty much everything in fish. And even the system, like the bones, how it's made, you have the biggest diversity of all animals, except maybe insects, in fish. It's the same for olfactive, because fish are communicating, many fish are communicating by chemicals, because it's easier to release into water. And so they have an immense amount of different kind of perception for chemicals, like catfish can taste at a distance. What? You have fish that have an entrance nostril and an outside nostril, because the mouth and the nose aren't connected, as in us. So, anyway, now I'm gonna pick some of the most amazing things we've discovered in fish. Well, amazing and easy to explain in a short amount of time. And one thing I really like to do is taking things we thought were uniquely human and showing them, hell no. We're going to talk about tool use in fish, because we discovered, if I remember correctly, the first discovery was somewhere around 2009, 2012, 2022, maybe 2012. No, I think it was 9. Anyway, it's very hard to use tools when you're in the water, because many tool use we use hands, which fish massively lack. But also we use gravity. Like if I want to swing a hammer, I use gravity. And when you're in the water, that's much harder. But we found some really weird behavior. This one has been filmed pretty recently, and you might have seen it. I stole it from BBC Blue Planet 2, and it's much better than the video from the scientists, so I'll let you watch it. And I have no sound. Okay. So one thing very interesting about this video as well is that for once we had the occasion to see a fish behaving like in his everyday life. Because it's one thing that split us from them, that we don't see them living. You see birds, you see your cat, you see your dogs, but you don't see fish. And here, this fish is mainly eating shellfish, and he's searching for something to eat. this is what's great about my job. I don't even have to speak. They're just showing everything. And there, it's very interesting because you see the fish taking the shell and bringing it somewhere, which means that this fish has an intentionality in what he's doing, or she's doing, or they're doing, because in fish it's very complicated. This one has a goal. Let's say she's a female. She's going somewhere. And this somewhere is this kind of reef stone. And you can see that it's pretty, it's damaged at one point.
Where is this?
I don't remember. Well, probably near Australia, where most of this stuff are filmed. And very interesting. So it's really hard to use tools when it's in water and when you use your mouth, for example. For another example. But the thing that's crazy is that this fish is using, when he managed to, uses this coral reef as an anvil to break the shell. And if we really take the definition of tool use in science, this doesn't fit. I have an example that fits right after. This one doesn't fully fit, but it's even very interesting because we never thought fish could do that. And actually, the fish have a very specific place, and she can swim for a long time just to break the shell. And at some point, we will see the place from the top, and you see there are many older shells because each fish has her or his anvil. You see everything around. And this is one thing we tend to forget, that fish have their own lives and they have challenges. And these challenges, they have to do something about it. They have to overcome them. And they do. Now I'm going to show you something that is honestly one of the most mind-blowing things I've ever seen. So this study is pretty crap. Well, not the study itself, but the goal, because it was made for aquaculture. And the idea was to test, it was the food preference of the fish, it's Atlantic cod. And the idea was we put a self-feeder and we see which fish goes to the self-feeder, what he eats or she eats. So basically, I'll show the video after, but I need to explain first. You have here a small stick that is tied to a rope that goes to the self-feeder mechanism. So when the fish pull on the very, very small black stuff that you might not see, but you'll see better after, the lights switch on and the food is delivered here. But that sucks, because if you use your mouth to pull on it, well, the food is here, your mouth is here, so you're not the first one to eat the food. Right, okay. Now, leave that aside. Another thing, the scientists can't discriminate properly who is who. So to recognize each fish individually, they put a tag on the back with beads, with the colored beads, so they know this is bluefish, this is pinkfish. And what happened is, at the beginning, every fish was doing that perfectly. They were going, grabbing the stick, pulling the stick, the light switch on, the food gets released, okay, we have food, everything's good. But 3 fish, but I stick to one fish got locked in the stick. He got totally blocked, he rolled it around his beard. So he's panicking, he's trying to get away, and the self-feeder is activating, the food is delivered, okay. And the weird thing starts now. After very shortly, the fish started to try voluntarily to grab the stick with the beads in its back. And after 11 days, which is the end of the experiment, the fish used the mouth, it was 51 times, and the beads 422 times. And what you see here is, can I zoom on it? No. What you see here the cross, the center of the cross, is the position of the self-feeder mechanism. The circle is where the food is. All the lines are the 10 first trials of the fish to try to grab it with the tag in its back. Here you can see the 10 last. What we can get from it is that the fish has developed a technique, a very precise technique, and the 3 fish who did that had different techniques. They're coming up, taking the stick, pulling, releasing themselves, and having the head under the food, which means that now they're first to have the food because they're activating the system with the back. And now I'm going to show you that. So this is how it works normally. So the fish is taking the feed over the mouth, pulling, and the food on the top right. Okay, now it's when it got trapped. You see, the fish is not moving anymore, it's blocked, get released, and now you're going to see the last one of the last try. Get ups, grab the tag, and eat. So let's be clear about what we're watching there. You have an animal that is using a prosthetic limb in its back that it can't see, to use a self-feeder, to use a tool to get first at eating, which has not been planned by the scientist. We have nothing alike in any other animal. That's really, really impressive. And now it's getting scary because I have much more impressive things. We're going to talk about the cleaner wrasse. Is there anyone here that knows this fish already? Oh, God. Oh, you do. Oh, you don't know what's coming. Okay. This fish is actually smashing everything we thought we knew about cognitive science. And all the question of sentience and everything is pulled back to zero because of those assholes. So, what is their life? Because we have to start there to understand. So these fish are cleaner wrasse. They are cleaning. Their job in the water is to remove, to eat the parasites and the dead skins of other fish. But let's be clear, no one here likes to eat parasites and dead skins, I hope. But these fish, they like to eat the mucus of the fish that are coming. So the mucus is the protective layer on the side of the fish. And the clients, because we're going to call them the clients hate that. We call that cheating. So how does it work? You have a station, so a fish comes out of place, it becomes its territory. And, hello, and he's there and he's cleaning the other fish. And as you would find in any good cleaning station, at some point you will see another fish come queuing. You see, I have another client. The fish switched to the other client, which tells us something about this other client. It tells us the size of its territory. Okay, now let's dig into the very complex stuff. So, these fish are cleaning. All right. They can have something like more than 2,000 interactions every day with clients from more than 100 species. We know that they know individually every of their clients and memorize at least their last interaction, which is already pretty awesome. But they have different kind of clients. For example, if they have a predator, let me tell you, they will not cheat on predator. Predators will always have a very good cleaning, really good. And if they get nervous, the cleaner wrasse are going to rub their back with their fins. They're giving them a massage. Now you're thinking, Sébastien, you're going a bit too far. I'm not. There has been studies to try to find out, does it count down fish as it does for us? Answer is yes. There has been some studies measuring the cortisol level, which is linked to stress, and also the aggressive behavior in 2 different fish species, and we showed that it appeased them. And this is exactly what happened when you take a cleaner wrasse and move him, and it's him this time, we'll see why. You move him somewhere else, he will first rub the potential clients around to build a clientele. This is how it works. So, okay, we have predators, but we have also vegetarian fish. So on the side, we have the vegetarian fish that have a very big territory. And on their territory, there are many cleaning stations. If these fish are not satisfied with what's happening at the cleaning station, they will go somewhere else. This is why the fish switched to the other one, because the first one was probably a fish who is a resident with only one station on his territory and a vegetarian. These are the losers. So the fish are very careful about the fish. I mean, the cleaner wrasse are very careful about their image. So if there are other fish queuing, they will not cheat to not make them leave. But if you're a resident with only one station, not a predator, and there is no one waiting, here is what's going to happen. You see, he bites the client reacts immediately and chases the fish because this is the only thing they can do. And in this case, the cleaner wrasse will remember that, and next time he'll have a 5-star cleaning. That'd be very good cleaning. But it doesn't stop here because their society is basically a harem. So you have a male, but when they're getting born, they are female. Only female. And after a certain weight, when they become too big, one will switch to a male and will be the leader of the station. So basically, he will make sure that the female aren't cheating, aren't biting clients and lose their clients. But something else, they will have to keep the biggest female aside and be sure they're not eating too much, because otherwise they might turn to a male. A rival male. So they're very cautious about whether she eats too much or not. And one very interesting thing is that the female knows that the male is doing the police. So when they want to cheat, we've discovered very recently that they tend to get out of his field of view, which hints at what we call theory of mind. It's too early to talk about that, but it could be that she knows what he could see and try to get out, to get away. And this would be a massive scientific breakthrough. But now we're too short now to conclude that, but it's a hint. So we have a fish that has a very, very complicated word. So obviously some scientists wanted to check how far they could go in cognitive capabilities and compare them to other animals, here chimpanzees. So I'll start by this study. This study is pretty simple, basically. You have 2 plates, let's say a red plate and a blue plate. The red plate is always available. You'll have it at any time. The blue plate is temporary. So if you start to eat in the red one, I remove the blue one. So you only have one food. If you start by the blue one, I'll let you eat, and I'll remove the blue one, so you have the red one. So if you want to eat in both, you have to start by the blue one. It looks pretty simple, but yet the cleaner wrasse were immensely better than chimpanzees, orangutan, capuchin monkey, and the daughter of the scientist, who never succeeded. But she was very young. But it's really interesting because it's pretty normal when you think about it. If they're making a mistake, their clients leave. They have to know what clients will stay and what clients will leave. This question, this special task, is very well attuned to the world. And this is why only the white-caught fish, and they have been released in the wild after, the white-caught fish are the more able to do this. because they had experience in something pretty close. And one very interesting thing is that when you bring back the blue plate, they are rubbing the blue plate. Because for them, food and social interactions, it's one and only thing, which explains why punishment might be even more important. Another study is this one, which is, holy hell. So, it's the most complicated one I'll explain today, so I'll try to be clear. We have a red plate. In this red plate, you have crab flakes. Okay, the fish likes it, but bleh. Okay. So at the start, we give them the red plate every 5 minutes. Okay, you have it, it's already there. Okay, now we add a new plate, the blue plate. So in the blue plate, there is a flake of shrimp, and they definitely prefer shrimp. So every 5 minutes, we bring the two plates and we see what they do. They go to the shrimp. Okay, but the scientists decided that the blue plate is only available every 5 minutes. So what happens if they present both plates after 2 minutes and a half? Well, if the fish goes on the plate with the shrimp, they remove both plates, so it's full loose. Now they present the red and the blue every 2.5 minutes, and very quickly the fish understand that first time I can go on blue, second time I go on red, third time I go back on blue. That doesn't require a notion of time. That just requires to understand one, I switch every time. But the idea is to see how much they understand the notion of time. And so now they bring the green plate and the yellow plate. The green plate is available every 10 minutes. The yellow plate is available every 15 minutes. And they start to mix everything. So suddenly the fish has green and a yellow and this kind of thing. And it has to remember, like, okay, this one I ate in this one 10 minutes ago, this one was 15 minutes ago. Okay, this is this one. And they can do it, while I don't think I can. Really, it's very hard. But also, this is understandable because in their everyday life, the clients loves being robbed and being taken care of. So they often get cleaned, leave, and come back queuing immediately. And we know that cleaner RAS remember how long it was that this client came and are accepting or not to clean this fish if they think that, oh no, you didn't have time to get new parasites, go away. And so, obviously, the scientists wanted to go further. We have a fish that can outperform primates, which is ouch. And they gave them one of the most famous tests, maybe you heard about it, which is the Moro test. So the Moro test is usually presented as a test to assess self-awareness. It's been developed in 1971 for humans. So the idea, basically, is you take an animal, human or not, that has never seen a mirror. If this individual has the ability to recognize itself, what will happen is, first time you are in front of the mirror, you should think you have another individual. So we should see social behavior like aggression. Okay, this is what we see in human. Then the next step, the animals should notice something is wrong. So we should start to see behavior that are not belonging to the usual library of behavior. So, for example, human or chimpanzee that will start to move the hand to see if the image is reflecting that movement. If they start to understand that, okay, there is something weird with this animal, and they understand, oh, damn, it's me, they will start to try to look at parts of their body they normally can't see, like the inside of the mouth, or for human, the buttocks. Then, if all those steps are valid, we put to sleep it. Can it be used not only for killing? Well, they put them to sleep, but they're not killing them. I'm talking about anesthesia. And they're sleeping, and then we draw a mark on them, usually on the temple or on the top of the chest. And when the animal is waking up, the question is, will he or she, by looking at the mirror, understand there is a mark on the body and try to remove it? Okay. And in this case, sometimes we say they are self-aware. This test is problematic for lots of reasons. It's very vision-centered. For many animals that uses chemical communication, it's way less useful. We're not really sure of what it tests, because recognition that it's your body is not the same thing as self-awareness. But anyway, when it's been done in chimpanzees, everybody was like, whoa, chimpanzees are self-aware. I'm not sure 100%, but the stats were something like 100 or 200 chimpanzees tested and 30 succeeded. For elephants, it's like, whoa, elephants passed the mark test. Okay, it's 3 elephants, which scientifically is very bad as a number, and only 1 succeeded. And it goes the same with most of the animals that passed it. For example, for dolphins, how do you want dolphins to try to remove, not the mark is here, to remove the mark with fins? So they can't. But because it's dolphins, and we think dolphins are intelligent, when this test has been done on dolphin, everybody said, that's okay. And now, we are in 2019, so pretty recent. There is a first study from a Switzerland-Japan team that released the first mark test done on fish, on the cleaner wrasse, obviously. And the thing is, the success level is insane. Like, it's very, very high. All the fish are passing it, except 2, I think, but because they think they already recognize their image in the reflection of the tank, and therefore it screwed a bit the classification. And then, okay, when they released it, it was not a fish passed the mark test, they are self-aware. The study was named something like, if a fish can pass the mark test, what does it mean for the mark test? And I agree with this question. This test is questionable, but yet the results are amazing. And as they knew people would wait for them and to break their knees, they were already preparing new controls, new tests. And a few months later, they released a second paper with the same result, and they're 100% success. We only had that in human. It's not all. Last year, 2023, the fact is, when you want to put a mark on a fish with a mucus, you can't really do it. So they have to inject a very small stuff under the skin, which is a silicone. And everybody was like, yeah, but maybe the silicone is hitching them. The thing is, we know it's not the case, because when it's transparent, they're not trying to remove it. But anyway, they used photography. So this time, they are passing all the mirror test phases, which is pretty fun, because it means that now, for cleaner wrasse, passing the mirror test is just the training phase. So they're passing the training phase, and then we show them a picture of themselves with a mark. And we see if they recognize it's their picture, or if it's the picture of another individual, and in this case, they don't try to remove it. Guess what? They recognize their own picture. They know it's them. And the scientists were like, okay, but do they do like humans? Because for us, when we recognize ourselves in the mirror, we recognize the face. What did they do? Photoshop. This is exactly what you see here. They took the face of the fish and put it on the body of another cleaner wrasse. And then they did the opposite, the face of another cleaner wrasse on their body. It appears that they recognize themselves by the face. When it's the face of someone else, even if it's their body, they don't recognize it. But when it's their face, they know it's them. This was released last year. We never had anything like that in any animal, let's be clear. This is crazy. So this is why I was saying that they're just smashing everything, because the size of the brain, everything makes it so that they shouldn't be able to do this. And yet they don't care. Another really interesting thing that has been seen in fish is the behavior of groupers and moray eel. Why that? Because we're seeing an interspecific cooperation for hunting between 2 different species that have developed a system of communication between the 2 species at the initiative of the grouper, actually. So how does it work, and why does it work? But once again, how many animals on land of two different species do you know that are hunting together? There are not that many examples. There are some, but not that many. So how does it work? The grouper is a very powerful racing car. This is a very big fish, very powerful, and it can overtake any fish at swimming. But they're quite big, and they're living in coral reefs. So what happens is, if they start to race behind a prey, and the prey manage to hide inside the coral reef, then it's lost for the grouper. But the moray eel has a more snaky body, so the moray eel can get inside the coral reef. But it's pretty different, because here you have a very fast and powerful daylight hunter. Here you have not that powerful, but nighttime hunter. So it's really hard for the grouper at first to find a moray eel that agrees to come hunting during the nighttime or the daytime but it's nighttime for her. And the grouper has developed a communication to call the moray eel. So at first, when the grouper finds the moray eel and the prey has escaped already, he will come, or she will come, and start shimmering the head. So the moray is here, and he's shimmering and touching the back. It's a communication to say, come with me, we're gonna hunt. So then they're hunting together. It's the video directly from the study, so the quality is not very good, but I have better videos right after. So they're swimming along, which we really have to understand how crazy this is. This is two different species hunting together. So there will not be any sharing of the prey. It's either the grouper gets it or either the moray eel. And then, and this is the most crazy things, what you see here seems like nothing, but the grouper is indicating to the eel where did the prey go. This is what we call a referential signaling. So for a long time we thought that animals were just expressing emotions with the sounds, and we know it's not the case. One of the best examples we had for a while was chicken, actually. And in grouper, we noted that they get the eel, they bring the eel where the prey is hiding, and then the grouper points precisely the hole in which the prey has hidden, so the eel can know where to go, which is just crazy, because it's not an emotion, it's really pointing something. And another interesting point is, recently they tried to check if they were able to select the moray eels by their abilities, by their efficiency. And so what they did is they just mirrored another test that was happening on chimpanzees at the same time. So what they did is they put in a tank a grouper and a fake eel, and when the grouper was going for this eel, she was going under a fake coral reef, and it was releasing food for the grouper. And on the other side of the tank, there was another moray eel that was not moving. Even if the grouper was shimmering and everything, the moray eel was not moving. And we noticed that the groupers started to only select the efficient one. And they made a lot of tests, and it seems that they use the same technique as chimpanzees do to select their partners. And now I have another video that I absolutely stole again from Blue Planet. They have amazing videos. And this one is even more crazy, because you have a grouper and an octopus. So it's not even a vertebrate. It's like us having an activity with bees, which agrees. It's the same difference, really. So here you see the pointing down. For the people who are sensitive, in the end, the grouper will catch the prey. We don't see much blood or anything, but he just leaves with the prey in the mouth. And what is extremely crazy. It's really to see these two so different animals hunting together. The octopus understanding what the grouper is doing. The grouper indicating, hoping the octopus will understand. That's, once again, I have no example of something alike on the land. Okay, I'm going to rush a bit because I'm slightly late, but it's so interesting. And another thing is that we tend to think that fish don't make bonds together because many of them are using external reproduction and there is no parental care, and this is so wrong. You have some fish that have no parental care, but you have who do. You have who even have all the adults raising the babies with them. And here we are in fish that are pairing for life. And this study is very interesting because the idea was, do they behave differently with their partner and with other fish? And so the idea is, you take a male, so you have two tanks aside, one of the other. You have the first tank where not the subject, but all the fish will be, and the tank of our focal animal, who is the male of the pair. If the male goes, so you have two small boxes. If the male goes in the box with the red circle, he receives food, and the animal in the other side receives food too. If he goes into the red triangle, he receives food, the other animal gets nothing. So pro-social, anti-social. Now, what happens in different cases? Here, this is random. Here, it's anti-social, pro-social. If it's control, it means there is no one in the tank. It's pretty much random. If it's the mate, totally 100% pro-social. If it's a rival male, totally antisocial, you're not going to feed rivals. Now, new female alone, not the partner. You see that it's pretty much pro-social, but there is a wide difference between fish. Why is that? It's because at first, they will act antisocial. And if they have been separated from the partner for something more than around 10 days, they will start to behave pro-socially, as if they lost their partner. And what happened if you put a new female, but in a tank just next, there is their female? Here is your answer, totally antisocial. So now we're going to go briefly on assessing sentience and why there has been a big debate around that. If there are some specialists of the question, I'm sorry in advance because it's very complicated topic and I'll go briefly on it. So it might be a bit rough sometimes. So there are different kind of definitions for sentience, depending on the authors. We'll go by the capacity for felt emotions. That is the one used in ethics and the most important one for that. So, sentience, first thing to understand is that when you want to assess emotions in animals, usually there are three components. One component is physiological, which is when you're having an emotion, your heartbeat goes faster. You're getting warmer, you have cortisols. Okay, so that we can measure. We know how to do it. The thing is, the further it is from human, the harder it is. But I'll come back to this. Then there is behavioral. So, for example, I win the lottery, I'm jumping. Okay, you can see my behavior. I seem happy. Okay, we can do this. But then there is the subjective aspect, how I feel, me, inside me. And this, we have no access. And this is where the definition in science between emotion and feelings arise. When they're studying emotion in animals, they're almost always referring only to those two parts because it's very hard to access the mind. It's really clear. I cannot know what you're feeling right now. When your kid, if you have kids, is saying, oh, I don't want to go to school, my belly hurts, you don't know, and you will never. So we don't know how to get into other animals' mind. But we can have indications because our emotions our feelings can influence our behavior. And in fish, it's been a very, very big question because there are massive economic profit behind. So the thing is, we know, I can understand if you're feeling pain, if I know that your body is the same as mine and I feel pain, your behavior looks the same, and we're more or less the same species. But the further you get from human, the harder it gets. Because, for example, the parts of our brain that we think process felt pain doesn't exist in fish. The nervous ending that we have that transmits the conscious pain are in a very short, very low amount in fish. They have other kind of nerve endings. So it becomes harder and harder. And basically, we had studies. So in 2003, we had this very important paper, Do Fishes Have Nociceptors? And it's not in this paper, it's in a book she wrote after, but Victoria Braithwaite, who is the director of the thesis of Lynn Snedden, who was working on that, said, I have argued that there is as much evidence that fish feel pain and suffer than there is for birds and mammals, and more than there is for human neonates and preterm babies. And it was one of the first studies. Since then, we have way more information. And we now have all the physiology part. They discovered where the nervous endings were, how they were transmitted to the brain. We know by this study that it's just a few studies taken. We have more than 50. We know that if you touch them or if you pinch them, it's not reacting the same way. It's not the same parts of the brain that are activated. Here we found the different parts of the brain that seems to process pain. Then we had cognitive and behavior ones that are very interesting. Do I have time? Yes, I do. For example, this one. It's been done on rainbow trout, who has been actually almost everything we know about pain in fish has been done on rainbow trout. So it means that on most of the fish, we have no damn idea. We don't know what's good or bad for them. For example, trouts don't really feel cold. Their thermoceptors aren't reactive to cold. So they can get to very cold temperature. So how does it work? Trouts are neophobic. So when you put a new object in their tank, they will fly away. But if you hurt them by injecting acid in their lips, then this neophobic behavior disappears. The fish is bumping in the object as if its mind was taken by something else, like pain. It might be an indication. And if we give the fish an analgesia, the normal behavior comes back. So this is not a perfect clue, but this is a very interesting hint, especially as we found that the full anti-predator behavior disappeared. But the thing is, very interesting as well, it was in truth, if you take a trout, a dominant trout, and you hurt it, and you put it back in its family or group where it's already dominant, it will not have any dominant behavior. If you put the same fish in a group he doesn't know, he will act as a dominant and try to fight its way up the hierarchy, which means it's not a reflex. They have control. Because, for example, the behavior, when you put your hand on something very hot and you remove it immediately, you had no consciousness of that. So the behavior itself cannot inform you enough. But if the animal can control it, for example, on this study, there was a tank split in different parts, and if the fish is on the left side of the tank, everything is good. And the more he goes on the right side, the more he gets electric shocks. And normally, the fish will never leave the left part of the tank. But if you put rewards on the other side, it will accept more and more to go there. So the animal has control on it. This one is very interesting as well because they wanted to see if the evaluation of the animal of the situation was important. Because if it's reflex, if there is no cognitive treatment of the information, what's going to happen is you put a stimuli, for example, something positive. I give you food, and if it's the food that produces the result, you will always behave the same way. If there is a punition, like I remove the fish from the water, he will always behave the same way. But what happens if we make it predictable or unpredictable? then it's the evaluation of the fish. For example, here there is a positive stimulus, food, a negative stimulus getting put out of the water, and they can be predictable. There is a light that switches on just before, or unpredictable. The light has no point, has no relation at all with the treatment. We see that the behavior, the physiology of the fish are different in every cases, which means that it's not just the negative stimuli that provoke the emotion in the fish, how we react, but it's the evaluation that the fish has of the situation, whether it's predictable or not, that influence this. And so more and more we had a person like the group of Rose. So James Rose, when you will talk to fishermen or industries, you will always have the name James Rose coming up, because he and his group of friends have been doing reviews and reviews and reviews saying, no, we don't have enough clues for sentience in fish and it would impair the industry. And some of the arguments they raised are interesting and are valid, so that pushes us to go further and again further. And today, we are trying to find out exactly how to be sure that an animal, human included, are sentient, because we discovered that we don't really know how to assess it correctly. We can have a lot of hints, and using these hints to say, okay, we're pretty sure about it, but to be really absolutely 100% sure, even human, we can't do it. And this is exactly what we see in very recent studies, like this book. If you plan to work on fish, the book, The Welfare of Fish by Christensen, it's kind of massive stuff with many authors in it. It talks ethics, it talks animal consciousness. It's a very good book. And Mason, for example, who are specialists in consciousness, who are actually saying, we need to do more study to understand exactly what sentience, to find good criteria, but for fish, we have enough clues now to take regulation, welfare, this kind of stuff. And the consensus now is we are as certain, we have the same level of certainty that fish are sentient than for land animals. And what now? What now? Well, the insects are the next step, because we're starting to have pretty strong hints in Diptera, which are flies and mosquito, and bees. And actually, the most amazing results are bees. And one of the main world's most renowned scientists, who is living in London, actually, Lars Chipka, he said already many times that for him, bees are sentient. And the results we have of studies tend to go that way. And they recently received a grant to work on that. So at the very moment, they are releasing studies about this to show whether bees are sentient or not. And it seems like they are. Thank you for attending this time, for listening to me, for bearing my accent.
All right, we've got time for maybe 2 quick questions. So, right, we'll go. And then, does anyone else have one? Or there's some on the app as well.
I actually have 3 questions, so should I just do one and come to you at the end for the other 2, maybe? Really cool talk. Fish are often overlooked, so thanks for doing that. I'm, like, in my academic background, I'm a zoologist, and a lot of the conflict that I had internally when I studied zoology was how do I justify the sort of experiments that we do on animals. So you talked about like the beads on the fish. How, as vegans and as animal rights activists, can we justify, I get that we're trying to like understand more about the species, but how can we justify that just to advance our knowledge on them?
Well, the example of pain in fish is the best example for that, I think, because to show that an animal feels pain, you have to hurt the animal. And it's really complicated because from the knowledge we had until then, we had everything to believe fish weren't conscious. It was pretty clear and pretty certain. The preliminary results we had were fish are not sentient. So it was impossible to have any regulation or anything. And now the new studies allowed us to fight with this. And this is really, really complicated. Honestly, in the frame of my work, I try to put in front ethical studies as much as I can. For example, the cleaner wrasse, it's been done usually on wild animals that have been captured and then put back where they have been taken. So it's pretty okay, let's say. But the funny thing is that when they try to catch the same group 1 year after, they can't. The fish remember after 1 year. But I don't have any answer for that. But I tend to hope, and I hope it's not cocky to say that, but as in France, I'm one of the only person doing what I do, and the scientists have been really interested to have people talking about their work. And the fact that selecting special work to talk about, which are ethical, and I usually talk, even if I try to not go into ethical because this is not my field, but I still take that as a basis as much as I can on the study. Well, it influenced somehow some scientists to go to better stuff, but even in the community itself, I've met some young scientists who actually started doing science on animals, ethology and this kind of stuff because of my work. And this is pretty crazy because they're working at making those animals more recognized, and in their studies they're trying to do things better. Like I've met one guy recently who, so he's a PhD in ethology, and he's also a veterinarian, and he's trying to advocate to teach veterinarian how to take care of fish because none knows how to do it. So it's very, very hard question.
Yeah, sorry.
No, you're right. This is. I knew I'd have this question, and the information is here, and we have to use it.
Does anyone else have a very quick question? All right, go on then.
This actually is a quick one, hopefully. I don't know if I need this. So the video you showed of the grouper with the octopus, have we got any evidence that the grouper ever gives the fish to the octopus at the end? Or could it be that actually when the grouper sort of goes above the reef and makes those indications, it does that knowing that the octopus will then try and sort of steal the prey for itself, knowing that that will drive the prey out so the grouper can go in and catch it? So yeah, hopefully I worded that and made that make sense. But yeah, do we have any evidence of the octopus actually being given the fish from the grouper?
So they're not giving the fish to grouper. Everyone is trying to get the fish for themselves.
Okay.
Pretty clearly, there will be no sharing, but this is why they will hunt together for a little while, for that everybody gets some food at some times. But yeah, we know that groupers, we have evidence that groupers, when a prey has been hidden and they don't know very well the area and they can't find a proper partner, they will point for going up to 25 minutes. One grouper has been seen pointing for 25 minutes, and they will accept pretty much any fish coming that can help them. For example, you have fish with very strong teeth that can just break the coral, and they have been hunting with them. And recently, I have a friend who totally randomly said, "Oh, I was a diving teacher in the Caribbean, and I've seen a grouper hunting with sharks." Like, what? And so he's actually, I told him to send this immediately to Red One Chari, who is the guy working on that. And he did. And Chari answered immediately like, what the hell? And they're going to make a study on that as soon as possible.
Yeah, that's really cool. I've got one more question. Is that really awful?
What time is it?
5 past.
Is it 5 past?
3 minutes past.
Yeah. There is a pause, I think.
I think there's a break now, so maybe I can. So it's more like on your last point, when you said the next stage would be looking into insects. So I don't know if anyone else has witnessed this recently, but I've even had people in person ask me, how do you classify things like mollusks, specifically oysters and mussels, which I appreciate aren't fish, but still aquatic life. So hopefully you might be able to answer. So a lot of them, like people on the internet, are trying to claim that they're technically vegan because they're so sort of almost plant-like. I know they're still animals. So how would you justify that they are sentient and it's technically not a vegan product if you eat them? Because I have been asked why I don't eat them as vegan, and obviously I don't, but yeah.
With the actual knowledge, the chances that bivalves our sentience is low. But nobody tried anything on them. The thing is, we think it's low because, as usual, it's by comparison with human beings, because this is the only experience we have. We are human beings and we can't get out of being human beings. And the thing is, these animals are so different. We know that for us, you need special nerve endings. You need type C and type A delta fibers. We know that there is a special system that transmitted to the brain. It seems that to have a conscious experience of pain, you need to have a central brain that can process and transmit to different areas of the brain. Those animals have no brain. Their nervous system is really, really small. So, but could be something really different, but according to what we know today of how pain is processed, the chances are low. But another important thing is that you can be conscious without feeling pain. There are human beings like that. Like, consciousness is a much more complicated thing, because consciousness is like, it seems to be like an addition of different subconsciousness. There was a case that is amazing. If ever you want to see it, it's on YouTube. It's called blind sight phenomenon. And there is a human patient like that. He had a few strokes, and no, it's not stroke, but I don't have the word in English, so you have to deal with stroke. And a part of his visual cortex has been destroyed. And this guy is blind. He can't see at all. And if you ask him what's on the table, he'll go like, I don't know. But then they had a feeling, as the eye is working, the optic nerve is working, and all the primary areas are working. They had the hint that he could maybe see without being conscious of seeing. And then what they did is they've asked him to cross a corridor. And in the corridor, there were obstacles everywhere. And the guy is literally walking like that. You can check on YouTube. You write blind sight. The guy's walking like that. And he's avoiding every object. And in the end, they ask him, why did you walk like that? I have no idea. And the guy is blind, but he sees. But the part of his brain that deals with conscious seeing, vision, is gone. And so it makes things really complicated about what is consciousness, what it's not. So I can answer in probabilities, no more.